Hello, class. This recorded lecture is a continuation on section 5.5, and this one is going to focus on a technique called synthetic division. And so in the last lecture, we talked about long division, and as you realized, it is incredibly tedious. And so it is much easier to make a mistake when the process is tedious. So what synthetic division does for us is makes it way less tedious. And so if you can use synthetic division and become comfortable with it, I would highly recommend that you do that because you're going to make a lot less mistakes in the long run. Again, just because the calculation is a lot more straightforward. The one thing about synthetic division, though, is the only time that you can use it is that what we're dividing into is a linear factor, meaning the zero is actually a linear zero. And so what we mean by that is this is linear, right? X minus 2, that would be a 0 of 2, or x plus 3, that would be a 0 of minus 3, et cetera, et cetera. Now you can't use synthetic division if, for example, we had x squared plus 4. Here's a quadratic now that we would divide into, and we'll see in the next section, we're going to talk about complex zeros, as they would call. And you would see that this would end up being plus or minus 2i. And so the only way to reduce the polynomial with division when it's not a linear would be long division. So you can't just throw away long division. But you'll see that most of the time we'll be able to use this synthetic division approach. So let's go through the same two examples that we did in the last section, or last lecture, excuse me. As I write this one down, this should be 6x squared plus 11x plus 6. And so if you remember, we did this one, I think we divided the minus 2 x-intercept into this. So that was x plus 2. Let's do a different one. So in this case, we had x plus 3 as the factor. So that would imply that the x-intercept would be minus 3. And so the way to set this up is you use the actual x-intercept, or 0, here for the calculation. And then what you do is you put columns for all the factors that we have here, all the terms, excuse me, all the terms that we have there starting at the highest degree, or the leading term. And then you put all the coefficients right here. And I like putting this up here because it just reminds me of all the steps that you need to do. And so the way this works is that you always bring down the first coefficient. And so what's really nice about this, it'll be 1 times minus 3. And you put that right there, and then you add the columns. So much less tedious, right? So once you have it set up, it goes pretty quick. 6 minus 3 is 3. 3 times minus 3 is minus 9. 11 and minus 9 is 2. And then 2 times minus 3 is minus 6. And the good news is we got a remainder of 0. So the factor that we have is x plus 3, because the 0 is minus 3. So how do we write the equation? Well, if you start with the cubed, this is the coefficient of a square. So it's 1 less than what you started with in the degree of this polynomial. So this would be x squared. This would be the x term, so that would be 3x. And that would be the constant term, which would be plus 2. So you could see, on personal note, I try to use this technique when we're doing linear x-intercepts with regard to that. So let's do one more. And so this one, we did x cubed minus 7x squared plus 6. And that was x minus 1 in this case. So that x-intercept or 0 is 1. So this case, we'll put a 1 here and see what we get. So this is x cubed, this is x squared, this is x, and this is the constant. So we have a 1, we have a minus 7, and you see we're missing the linear term here, so you have to put a 0 here. It will not work without that, so that's why I wanted to do an example this way. And then we put the 6 there. Again, you bring down the 1. 1 times 1 is 1. That would be minus 6. Minus 6 times 1 is minus 6. So you add this again, you get minus 6. Minus 6 times 1 is minus 6. And you see we get our 0 remainder. So here we'd have x minus 1 as the factor. And then that would be, since it's cubed, it would be squared minus 6x minus 6. So that ends the recorded lecture for synthetic division. And the next couple lectures are going to go over some really important theorems to be able to find the zeros of an unfactored polynomial.